Ecosystems, and today with us we have Tanja Fransen, who is a meteorologist in charge at NOAA. That's her title. I love it. She's from Glasgow. That's impressive in itself, in that we have somebody from the eastern part of the state to talk to us. We don't see folks from there giving us talks very often, so that's great. She leads a team that provide weather, water, and climate services to northeastern Montana. She was the warning coordination meteorologist in Glasgow for 15 years prior to her current role. And her focus is on impacts, decision support, and Weather Ready Nation, which is a program, and maybe we'll hear a little bit about that. She is a member of the Montana Disaster Emergency Services Association, the Glasgow Levy Committee, and is the former chairperson for the Montana Emergency Alert System. She received her bachelor's degree in earth science and meteorology from the University of Northern Colorado in 1995, and she spent the last 25 years in the High Plains. So, welcome, Tanja. And
so I want to start with, I work for NOAA, which some of you think is the National Oceanic and Atmospheric Administration, but it's really the National Organization for the Advancement of Acronyms. So if I slip some in there and you're not sure what they are, raise your hand and stop me, because it's such a part of our culture to use them that I forget that not everybody knows what I'm saying. So yes, I've been in Glasgow for 18 years now, last 4 years now as a supervisor. My previous job was kind of the outreach person, so going out and working with communities, building relationships and building ties. One of the things I've mentioned to some people already is in 2007, Hurricane Katrina hit, and that same fall, a program started down at NCAR in Boulder in the Societal Impacts Program called Is. Weather and Society Integrated Study, moving from what was the way we do things to how we are going to do things in the future. And that really brought in the social sciences. And I finally thought, I found my home among the physical scientists. I don't know how I got through the math in college. I somehow did, but I'm a people person, and I want to take what we do in the Weather Service, what you guys are doing on the research side, and make it valuable to the people that we are serving. I'm going to throw in a little sidebar. I'm also on the council of the American Meteorological Society and the chair of the board on enterprise strategic topics. Under that board is a committee called Ecological Forecasting. I think I have Paul roped in to join that committee. We have Dr. Running from University of Montana roped in. If anybody else is interested in serving on a committee, and we always need student members, let Paul or I know, please, because we'd love to bring people from Montana in. They like to talk a lot about marine environments and marine ecology, and I'm like, fires. We've got a lot of issues out in the West that ecologists are helping with. Also, I'm the 2021 annual meeting conference co-chair, so I will be helping arrange the meeting in New Orleans for the American Meteorological Society in a year and a half. I would love to see papers from Montana. Boston is in about a year and a half is New Orleans. So I'm going to just pump that just a little bit because I'd love to see more Montana involvement there. Okay, the science of explaining tomorrow why the predictions you made yesterday didn't come true today. Okay, that's what you all think I do, right? We get paid a lot of money to guess weather. I'm going to tell you, when I started 25 years ago to where we are today in weather forecasting, we have come a long ways. You know, that bomb cyclone that hit a month ago in the Denver to Nebraska area, my brother called me the day before and he was complaining. He goes, 65 degrees, and because of you guys, they're canceling Aurora's classes tomorrow for elementary school. And I said, call me in 24 hours. Okay, not having looked at anything because I'm on vacation, but I have confidence in my people. Sure enough, the next day he'd been sitting without power for 5 hours. They had a 96-mile-an-hour wind gust and a foot of snow on the ground in Colorado Springs. So he says, you know, maybe you guys are onto something. So 20 years ago, school wouldn't have been canceled that far in advance. We wouldn't have done that. So we're coming a long way. And that is because of research coming in together and working with us operational meteorologists. Okay, this is the boring part for a lot of people, but the Weather Service just released its strategic plan about 2 weeks ago. The mission has always been the same. We want to save lives and property, but the vision is a weather-ready nation. I'm not going to stop all events from happening, but I can help make people, organizations, companies more resilient to the weather that we experience. And we can't do that if we don't have the research component involved in there. These are the goals. I'm just going to go through and highlight pieces. Reduce the impacts of weather, water, and climate events by transforming the way people receive, understand, and act on information. How many of you have ever had a weather alert on your cell phone? Okay, that's one of the ways we're changing things and getting information to people faster. NOAA Weather Radio is a great program, but if only 10% of the population owns one, we're not really getting the message out there in a good way. Harness cutting-edge science, technology, and engineering to provide the best observations, forecasts, and warnings. Those 2 GOES satellites that we've sent up in the last 3 years would not have happened without academic researchers who helped build the components that went into the private sector, who then went to NASA, who then launched the satellite that we're now using operationally. It took years to get to that point, but the latest science and technology, we have to have it, and that's not happening at the Weather Service Forecast Office level. That's happening in academia. It's happening in the private sector and the research communities that we have. So we need to all be together to make these things happen. Science-based service to the nation. A lot of our forecasters think we're getting soft. We're forgetting about the science. These are the models. I went to college and I learned how to read models and how to understand the models and make a weather forecast and tell you it's going to be 75 degrees this day and a 40% chance of rain this day. Now I'm telling our forecasters, you have to learn how to talk to the public. You have to look and see what research is out there, and you have to make that science that's out there and turn it into an operational tool that we then communicate to the public. So you guys are doing a lot of great stuff here. And I was just telling Kathy a little while ago, the folks that have reached out to us, thank you. Thank you, because we don't see MSU always as a meteorology school. But the other work you're doing from hydrology, the climate, the ecology side of it does impact our weather forecasts. All right, partnerships are essential for success. I have 20 employees, 15 of them are meteorologists. We can't do the research and do the forecasting and do all of it. So partnerships, we need you. We have to have what you're doing and talking back and forth. And what we're doing, if you take something and we give you the feedback from an operational perspective, then you can make it better and keep improving it because we're talking back and forth. It's not just a one and done project that's happening. And improving science and engineering for mission performance. So we're getting better and better. If you could see the 4-map fax machine type graphics I got when I first started in the Weather Service, we had this really old computer system developed in the 60s, and it seemed so archaic coming from a college and then stepping back into the operational environment. You know, we had kind of the cool tools and toys in college. And then I come back to the Weather Service and we didn't even have email yet when I started. Imagine that, 25 years ago, we didn't have email. Some of you are like, what? So science and engineering is making us better. We communicate better, we communicate faster. What is a weather-ready nation? Well, this was just the other day. We had April 3rd was Safe Place Selfie Day. If you guys had a tornado come through Bozeman and the warnings went off and all of our phones go off, what are we gonna do? Anybody? Personally, I'd stay in this room away from windows, but Safe Place Selfie, where are you gonna be safe? In your home, in your work, in your classrooms? What are you gonna do? We see weird things anymore. We're seeing tornadoes in strange places. Seattle had a tornado just south of there back in December that damaged some buildings just south of Seattle. So never say never. Just because you're in the mountains, you're not sheltered here. So Weather Ready Nation, what we're doing is we have an ambassador program, and we're asking organizations that are working to improve how the public responds to disasters, how they respond to weather, to sign up and be a Weather Ready Nation ambassador. I think having the Institute on Ecosystems as one of our ambassadors would be a huge win for me, to bring you guys in here and know that you guys are here trying to help make this state, this region, this area a better place with the things that you're doing. So this is the website. You can just Google Weather Ready Nation, but something I would love to see IOE part of this in the future. Let's talk about resilience in disasters a little bit. Even as good as Colorado Springs was with closing down schools, they forgot about the interstates. This is I-25. Okay. Few people were stranded out there because you got to go. My job's that important. I got to be on the highway, or I've got to go to that dentist appointment. And these people got stuck overnight. We're not to a weather ready nation yet. Nebraska dam break, March of 2019. They had more dams break in 3 days than in 50 years in the Omaha district of the Army Corps of Engineers. Was Nebraska ready for this? Nope, they'd never seen it before. We got to plan for what we might see in the future, not plan for what we've seen in the past. The Alabama tornadoes, March of 2019. We have people that go out and do these service assessments. They go out and they look at the damage surveys. We look at what happened out there. But now we need to start bringing in different sectors. We need to bring in the manufactured housing groups. Okay, 23 people died, and most of those were in manufactured homes. That's an engineering problem that we need to work on. A lot of them were not properly installed. That's a policy problem. I was telling somebody today, in Montana, you build a house in the city of Bozeman, you've got permits, you've got inspections, you've got things you have to meet up to. Go out to eastern Montana, out in the county. Anybody can put a house out there. It doesn't matter how it's built. And I've done enough surveys to tell you that they're not built well. Some of them are not done well. You know, if somebody puts in a $60,000 manufactured home, and if the installer doesn't strap it, it does no good when the 100-mile-an-hour winds hit from the thunderstorms. So there's a lot of components to building a weather-ready nation. Bottom right, the Montana drought of June of 2017. Were we ready for that? Not really. It came on really fast. First time I heard the term flash drought, and apparently there was even a published paper on that. This drought now is leading to publications as well, not only from your university here, but from the NIDIS group, the National Integrated Drought Information System. So what did we learn from that year to make us more resilient into the future? Okay, I'm gonna poke the bobcat. If I was in Missoula, I'd say I'm gonna poke the bear a little bit here. I saw this a couple weeks ago when my son sent me the funny video that came out afterwards about this, about the new, he knows which one I'm talking about. So Montana State Dean blames roof collapse on record snow and not the engineers. Okay, really? Just gonna poke a little bit, okay, because I still want to be welcomed back. The brown line is your average snowfall, and I ended this towards the end of March is when I grabbed this. The green line is your snowfall for this year. So your average up to that point is about 70 inches. You were up about 85, so you're only 15 inches above normal. But your record year was last year, 2017 and 18. So you're up to almost 120 inches. So that's a big difference from about 85 to 90 to 120. I might like to suggest that maybe last year's record snowfall probably led to some issues with the structural integrity. And then when I look at the data, and yes, I know it was taken at the airport, but I think no, this was taken at Montana State University. I actually took a picture of your co-op site as I was walking in here today. If you look, Your 24-hour snowfall, that day I went and looked, was 8.5 inches. Okay, that doesn't even make your top 30 24-hour snowfall days. Okay, so I would like to poke the bear a little bit and go, I think engineering might have had something to do with this. Age, inspections, and engineering. And look, you had your record snowfall the year before, but you do not see 2019 on this list. You know, your record 24-hour snowfall is 24 inches in 2009. The building held then. Okay, so this is where we need everybody integrated together. We can put out the best forecasts in the world, but if we have issues structurally, and we had a lot of buildings collapse in the state in the last few years because of heavy snow loading, maybe we need to design and re-engineer things a little bit different. We keep building things for what we know in the past, not for what could be in the future. All right, National Weather Service. There's 122 Weather Service offices across the United States. Everyone has a staff from 20 to about 24, 25 employees. New York City, Miami, they're going to have a few more people than Glasgow, Montana is. I only serve 50,000 people. New York City's got, what, 7 million people in the city. So, you know, they can have a couple more bodies. It makes sense to me. Here in Montana, we have 4 Weather Service offices. Glasgow in the northeast, Billings, south central, southeast, Great Falls, which includes Bozeman, and then Missoula has west of the Divide and into Idaho. So we're fairly similarly staffed. I think Great Falls, Missoula might have an extra body or 2 for fire weather purposes, but overall it's pretty similar. We are there 24/7, 365. This is why a lot of college students that major in meteorology end up not going into the Weather Service, because the shift works a lot. Not a lot of fun. And I remember I was ready to hop out as quick as I could and go to the management side. But bless them, they're rotating shifts. They're going from mids to day shifts and then day shifts to evening shifts. I think we have about 3,500 forecasters across the Weather Service that are in some way involved with shift work. We have electronics specialists. Somebody's got to maintain all those equipment, all the observation sites, the weather radars, the NOAA weather radio transmitters that we have. Observing specialists, they go out and work with our cooperative weather observers. They work on other observing equipment out there. I'll show a picture of them doing some snow core observations this year. IT support, you guys, if we didn't have IT support, we'd all be in a world of hurt, right? We rely on our computers daily. In Montana, we have 2 hydrologists. One is for the west of the Divide in the Columbia River Basin, and then one is in Great Falls east of the Divide for the Missouri River Basin. So he supports 3 forecast offices. Administrative support, and then we have our managers, and there's our acronyms. I'm the MIC, the WCM is the outreach person, and the SUE is the science officer. And I want to just quickly talk, because the SUE is probably going to be your first line of discussion if you're trying to reach out to a forecast office. They're responsible for implementing the new technology and data sets. They're also responsible for all training and scientific research conducted in the office. I'm going to tell you that there's been some good research coming from forecast offices, but it's always better when we're doing it with the university. Always, always better, because it's not what we do all the time. What do we do? So we issue a forecast twice a day using gridded forecast data. We can pull in computer models, we can pull in Ensemble data, but in the end, it's our forecast. We might know that in this pattern, the Milk River in Glasgow blows a lot stronger from a southeast wind than what the models are showing. Now, if we're doing our job well, we are giving feedback to the model developers, telling them, you need to up this. This is not always working out for us. But right now, there's so many different models that are coming our way, it's hard to look at everything. It's almost data overload. But you'll never find a meteorologist that says, I have too much data. It's just managing our time, looking at all of that data and trying to decide what's most important. All the watches, warnings, advisories that you hear when you see them on your smartphone, That's all the Weather Service. Now, the weather app on your phone may not be us, but the watches, warnings, and advisories in that app are from the Weather Service. We have data that we collect and quality control from surface data to the upper air. You can see the weather balloon there on the right side. We do aviation forecasting for the airports around the state. Again, economic. I met people last night in the hotel. Their flights were canceled already. They were supposed to fly from Bozeman through Denver today, and Denver's had a blizzard warning out. So that's an economic impact. Somebody's now had to shell out extra money. The airlines are losing money. And heaven forbid you shut down air traffic anywhere from Atlanta to New York City. Because you're talking millions and millions of dollars an hour when that happens. Here, very critical for us is fire weather forecasting. If we have a wildfire, that has the same workload severity for us as a tornado warning does. We have people dedicated to both of those because we've got people out on a wildland fire, and if that wind shifts on them or we get an outflow boundary on top of them, that can be a definite life-threatening situation. So those have equal weight for us. And then decision support services. One of the things we've really spent a lot of time on the last few months is ice jam flooding on the Yellowstone River. And I've always told people no two floods are alike. No two floods are alike. Well, this year the ice went through Glendive, which has always been our problem area. And we thought, oh, good, we're doing okay. Well, no, then it went up and it hit Sydney and Fairview, and we had tons of homes underwater. Lots of issues up there. So decision support services, we're working with emergency managers, we're working with MDT, we're working with Public Works on how can they best support their community with the weather information that we give them. So we also deploy to large fires and other incidents. The bottom right was one of our former IMETs, Jennifer Zeltwinger. They actually go out to the big, huge wildfires in the western US. We had one on the Lodgepole complex in 2017. Our IMET had just gotten deployed to Glacier the day before, so the Lodgepole complex had to bring in somebody from Mississippi. But these folks go out up to 2 weeks, and during the extreme fire year, they're out there for 3 weeks straight working 16-hour days. Now that overtime's really, really nice, and they tend to take great vacations in the winter, but it's a stressful job because people's lives are in your hands with your forecast. We collaborate and coordinate with partners in mitigation, planning, preparedness, response, and recovery. This is a very big emergency management role, and we have a big piece of that. Maintaining equipment, we've got millions of dollars in equipment that we're responsible for. Got to make sure it's all up to date and working correct. If you guys see data and you see bad data, you can go back and go, well, how is that system maintained? Because this place is consistently 5 degrees cooler than everywhere else. You know, you guys at the back end of the users of the data see some of those issues from decades past. And we do research. And again, I'm going to say I don't think we do it very well unless we're working with a university partner on it. There are some that are really good at it. I will say that, but in general, we do much better when we're partnered with a university. This is snow core observations, and Eric talked about this yesterday in a presentation in Roundup about better forecasting stream flow. Well, we have a lot of great satellite data, but if we don't have a way to verify that data and calibrate it, it's going to be off a little. And so we went out and actually took snow core observations. We send that data back to the, we call it no risk, National Operational Hydrological Remote Sensing Center in Minnesota. They're the snow people. We send that to them. They in turn redo their snow models, recalibrate it. It in turn goes to the river forecast centers. The river forecast centers then put out the flood outlooks, the different point in data that we have. So we're still out there hands-on as well. We don't have snow tells in eastern Montana, so we have to do this. We send them out on the road for a few days in really cold weather. All right, I wanted to come here and tell you I have got millions of dollars in research funding to help you all, and you'd be all excited and I'd be your best friend, but I don't. I don't have that. I know some of you have mentioned Science Foundation grants and things you're doing. I will tell you about one that I do know of through NCAR's Comet Partnership Program. The proposal's pretty short, 5 to 10 pages. Average award's about $15,000, max is about $20,000. The Weather Service pays publication costs. I know that gets some people. Basically, we're doing research to operations, and then operations back to research. So I'm going to show one of the projects that we have worked on in the past. This did lose some funding for a while, but it has been recently refunded. So this is something that has helped a lot of local projects for Weather Service offices around the country. So the University of Miami came to us and said, you guys are really cold. Let's do something with cold. And so the question we got most often while we were developing our cold project was, why aren't you working with Montana State University? Well, Miami is the one that came to us. Dr. Larry Cockstein is a biometeorologist. He was president of the International Association of Biometeorology for many years, and he developed heat health warning systems across the United States. Well, he wanted to talk to us about cold weather, and the more we looked, it was really hard to find cold weather deaths. We don't have a big enough population to look at mortality data. So we started looking at what the impacts were, and the impacts are to livestock. This study was funded for 3 years in a row. We developed it, built it, brought it to the users, used it 1 year, got their feedback, and kind of calibrated, redid some of the work in it, added some elements, tried it another year. And then we fine-tuned it for that last year. It's something we've been doing for over 10 years now as the cold advisory for newborn livestock. One of the papers I gave at AMS a few years ago, I went and I looked at what livestock deaths were in the US due to weather, and it's almost $1 billion a year. That kind of got the attention of our headquarters going, oh, you know, we look at people, we look at flood losses, but livestock is a huge industry in the high plains and the southern plains, different parts of the country. So this one here, like I said, has been running for almost 10 years now. We all see pictures of before and after, right? Here is Hurricane Maria, before and after. I don't know which tornado event this was, but when you can see the impacts, right? You can see the deforestation in the trees. You can see the building infrastructure damages. One of the projects that the Weather Service has spent a lot of time on lately is look at this beautiful town and how lush and green it is, beautiful campus. What happens if we're in the middle of July and August and it's 100 degrees for 3 or 4 days in a row and the overnight lows don't go below 70 degrees? What's it look like the next day? Well, let me show you. It looks exactly the same. We have mortality and heat deaths that are occurring, but because you don't see the big, huge devastation from it, sometimes it doesn't get the attention that it deserves. Okay, we're in a changing climate, as Kathy and I just talked about earlier. We're seeing things are warming up. We're seeing higher temperatures in places. How are we responding to that? We can show the research, but are we doing anything operationally to let people know? 2003, 70,000 people died in Europe during a heat wave. How many of you have ever heard of this one? It was right at the end of the school year, and a lot of young families went down to the Mediterranean and they left older people behind. There's not a lot of air conditioning. Families came back and found elderly folks and loved ones that had passed away from the heat. So Chicago, this was an article in 2015. So the Chicago heat wave was in 1995, 700 victims. Again, not a lot of air conditioning at the time. This was last summer, 70 deaths linked to Canada's heat wave. And then this one was interesting. I ran into this a few weeks ago. The Gulf will be too hot for humans by 2070. Well, it's already too hot for me now if you look at the temperatures there. But where are they building massive skyscrapers and trying to bring in money and people? In the Gulf. And yet they're saying it's going to be too hot to inhabit. One of the things we did, again, Dr. Kalkstein at this time, one of his grad students was now a pretty good researcher, Scott Sheridan, and he's at Kent State University. So we did another COMET grant. We looked at the heat system. And again, trying to find mortality data for the high plains. I mean, it took us all the way across the eastern parts of Montana, Wyoming, northern Colorado, Nebraska, the Dakotas, into western Minnesota to get 1 million people to look at mortality data, okay? So we were able to take a look at it, but there's new research coming out all the time. So Weather Service has transitioned now to the heat risk. This is something that you should see on our web pages in the summer. When I grabbed this last week, you could see there wasn't a whole lot going on, just a little bit of yellow showing up down south. So we're not quite into that time of year again. But when we start seeing red and magentas in Montana, this is something our health departments want to know about. Do they need to open up cooling shelters? Do we need to let the ERs be aware? You don't always see direct fatalities, but you see indirect health issues starting to happen from these things. If we can put out warnings in advance and let people know, find a cooling shelter, get off the farm or the ranch for a few days, come into town and stay with relatives. Those are the types of messages that we hope to do in the future. This is down here in Arizona, where you would expect a lot of heat issues to be. They actually worked with the Arizona Department of Health Services, the Arizona State University School of Geographical Sciences and Urban Planning. So again, one of those non-traditional partners that you can think of. And they've been doing these heat planning workshops on where are the shelters at, where are we going to open cooling rooms at. Putting ERs on high alert are things that they've been working on for quite a while down there. Forecast reference crop evapotranspiration. This was done by a science officer. She was a forecaster in Sacramento, became a science officer in Shreveport. She's now the supervisor in Monterey, California. But she did this one here with Cal State Monterey Bay and NASA, looking at the forecast reference crop evapotranspiration. So she was in California, Sacramento, the Valley. There's a lot of food produced there. They need water. California's got issues with water. It's either not enough or it's too much. So this was something ag producers had told them that we need help with, and so they went ahead and developed it. This was the poster she gave at AMS a couple of years ago. But it's now an operational product. It's automated, it's hands-off, so you can get that information here in Montana, and not even the forecasters don't even have to look at it anymore. This one's been huge the last few years. Atmospheric rivers. We used to just call it heavy rain. Okay, now it's atmospheric rivers. And you can see them, you know, our satellites are really showing some of this stuff pretty well now. But the Weather Service has been working with the Scripps Institute of Oceanography out in California, trying to show the impacts of an atmospheric river. You know, is it going to be one of those events where we're breaking dams and issues like that in California? Or is this going to be a favorable kind of an event that we actually need this moisture in some of the areas? So this literally just got published about 2 months ago, and is something that we're now, the Weather Service, okay, the research is there. Now the Weather Service has to figure out how are we going to put it into operations, and how do I communicate this to the general public, to the dam operators, to the irrigation districts, those types of things. Here's another one. This was a poster I did at AMS a couple of years ago after the 2015 smoke intrusions that we kept getting. The fires were hundreds and hundreds of miles away, but the public thought we were lying to them. We would try to tell them, well, in that picture there, you can actually in the background kind of see, we must have had a little bit of a vorticity max or something, because we had all these swirls in the smoke. It was one of my favorite satellite pictures of all time. But we can see this coming down, and we're trying to tell people the fires are 800 miles north of us. They don't believe us. No, no, I can smell it. We know you can smell it. So they thought we were lying to them. But One of the things here was the public health concerns. This is the first time a tribal nation came to us and said, help us, we need to get this message out. We have a lot of vulnerable people. I wish we'd have had time that summer to bring in the research side, but Colorado State University is doing some work in this regard. And I just heard today that that's something you all are looking at too, is the public health component. So this is just showing, this went back to 1980, and I know it's really hard to see from the back of the room. All you need to know is this big giant line here is showing over 160 hours of dense smoke in Glasgow, Montana. And you can see the next closest one was about 45 hours in 2003. Okay, now this stops at 2016. I think we'd have some pretty high bars the last 3 years too if we finish that plot. This was also the one NDSU Grizz game. Remember that one? In the smoke, you could hardly see across the stadium. Yeah, that was that year. So 2015, big smoke year. So what's now happening? We have the HER model. And they're now making the HER smoke model. Well, that's being done at the NOAA labs down in Boulder, but we're using the CERES labs, Cooperative Institute for Research in Environmental Sciences, and then CERA. I think one's at Colorado State, one's at University of Wisconsin in Madison. So we now have this. You guys, if you follow any of the Weather Service offices on Facebook, we were all showing these last year. Here's the smoke coming in, here's the smoke coming out. I have asthma. I know it's been impacting me the last few years when we have these big events coming through. Can we better forecast it? Yep, through science, research, and operations. Another one that's big is floods. This was a NOAA award, and don't ask me how the NOAA money got in there. I could maybe find people to help you get to that NOAA money. But they actually created this Focus on Floods outreach page through the University of Delaware, I think it was. But the stuff that they created is useful across the country, telling people how to prepare for floods, what to do with floods. So again, this is more of an outreach type thing and not a hard science. But if we can't communicate well to the public to get them to understand their risk, we're failing. We're not doing our jobs. This one here, Dr. Beryl Montz at Eastern Carolina University. Her grad student is now working for the Weather Service in San Diego. I tried to hire her in Glasgow and San Diego beat me to her. This one here is looking at ensemble prediction forecasting and probabilistic forecasting. How do our emergency managers look at our flood outlooks and relate the probability to what they have to prepare for? So I'm going to show you an example. This was our forecast for the Milk River at Glasgow, issued on the 21st of January. In a normal year, this is the blue line. This is what we could expect based off of ensembles of all the past 50 years of data. The conditional simulation, that is what we were expecting this year. So we were actually a little bit below the normal. Here's flood stage at Glasgow, 25 feet. We had a 20% chance of hitting that. Major or moderate flooding, we had about a 6% chance. And major flooding, we had about a 3% chance. Let me tell you what, we were wrong. That 3% chance, we hit major flooding and sat there for about 6 days. Okay, what were we missing? Well, that's where research can help us. What were we missing? We're pretty sure it was the frozen ground, but we didn't have enough data and soil temperature data to know how badly was the ground frozen. So when we warmed up, everything all went at once. And it's weird to have the Yellowstone and the milk go at the same time, but they did. So very, very busy. But this is somewhere we need work on in the future. But how do I explain this to an emergency manager? And is the 3% probability in January going to get them excited? Probably not, right? But there was still a 3% chance that we would hit that. It wasn't 0, it was 3%. This is the reason I didn't go to grad school, because there's big math formulas in here. But this is hard science. This is the physical science and improving some of the indices that they use for forecasting severe weather down in the southern US. So this was done through NC State University and several of the Weather Service offices down there. So this data, all that math, ends up in a graphic that we can look at and use within the Storm Prediction Center's website or in the model data that we have. So somebody goes back and looks at thousands and thousands of case studies and looks at data and finds, hey, this is giving us some correlations, and maybe we can improve our forecasting for severe storms. Next one. All right. Somebody should recognize this one in the room. Paul's chuckling there. This is when they came to us and said, hey, we have some data that we used from your upper air soundings, and we're finding that you guys were really dry in the mid-atmosphere leading up to the drought of 2017. It was one of the billion-dollar weather disasters that year. And to me, this is something that we can use for the drought early warning systems, the DEW systems that the Western Governors Association, the NIDIS, the drought group. This is something we have. It's kind of almost a predictive capability to look at in advance. I think we have some work to do in making it more operational. How can we see the data more in real time that you guys were looking at past, after the event had happened? So when I thought I learned a lot about cattle that are newborn livestock in cold weather, there's a whole other experience when your extension folks from MSU came up to Glasgow and talked about drought impacts on livestock. Water issues, nitrates in the cows, and the nitrates don't go away. They build up, and you know what happens? They abort the calf. And if you don't have a calf, you don't have income. Okay, so the drought, even though it was slowing and improving by September, October, you're still seeing aborted cows all the way into December, January. So the lingering impacts of this was something I completely didn't know a thing about until your extension specialist came up and shared a bunch of their information, and I looked at the papers that had been written on that. How does that help me as an operational forecaster? When I go out and I make my 7-day weather forecaster, probably not a whole lot, but how does it help me when I go out and talk to the public? It's a whole other story. You've got to have good water sources for your livestock before the next drought happens. So again, some of our stuff we do is short term, some of our stuff is very, very long term. One of the favorite things I've seen done in the last few years. We can talk climate and climate change all I want until, my blue in the face, but this has the graphics and the data, and it's not just coming from one source, the Weather Service. This was stakeholder-driven, science-informed is what it says. This is something I can pull out. In fact, Madison gave me the big copies. I mean, I had them online, but when you have the book and you set it down in front of somebody that's on the fence with this discussion, it really does show there's a lot of stuff that went into this. There's a lot of research, a lot of data, and a lot of discussion. So one of my hopes was, and so as I was putting this together, I actually went and looked. Montana, every county has a pre-disaster mitigation plan. The state has a pre-disaster mitigation plan, and what the Weather Service has been asking for is to incorporate climate change impacts, because you've heard me say it twice. What we saw last year is not what we're going to see in the future. Everyone in Glasgow thinks their levee is safe because it went through the 2011 flood. Well, go talk to somebody in Nebraska now, because theirs didn't even have deficiencies and they were breaking. Glasgow's has a deficiency. It needs to be addressed. So here's the state of Montana pre-disaster mitigation plan. I Googled and it was 471 pages. Don't print it out. But I did find on page 37 climate change in Montana, and it references the assessment. I was so excited to see that. I said, they finally heard us and they're finally getting these things. So Montana's not just planning for what we've already seen, they're planning for what we could see in the future. And this one made me really excited. We had the emergency management workshop down in Glendive to prepare for the flood season, and my emergency manager goes, "Have you seen this?" And we were busy that day. I said, "I haven't. Could you make me a copy? I'll look at it later." And I'm looking at it and I'm like, human ecology, learning, and problem solving lab. How cool is that? How cool is that? This is part of that weather and society integrated studies. How do people absorb what they're hearing and what do they do with it? And that's what they're doing with this research. So we had a great visit this morning and we're able to talk about this, and hopefully we can see the results in the future. How do people perceive their risks living on the Yellowstone River? If we can change the way we communicate the risk, maybe they will internalize it and see action versus trying to get out of their house at the last minute as the ice is coming up around them. Okay, and just because we're all science geeks, right? This is the Sentinel satellite. It's a polar orbiting satellite. I love satellite imagery, in case you haven't seen that yet. Here's the railroad bridge. Here's US Highway 200. There's the Yellowstone River. The flood is out to here. There's your two bridges. You can see the ice is brighter. There's the ice. So when this was sent to me by the National Water Center, I had just seen this picture the day before, and I'm like, look, I can give you almost a picture-to-picture correlation here of how cool the data is that we have these days to work with. So when emergency managers need to go back and kind of take a look and see how bad, how wide was it? What homes and what properties were impacted, they can go in here and they can see what is in that floodplain and what's underwater. And the article on the left, Families Face Uncertain Future. This was from the Yellowstone River flood. We bought Grandpa's farm. It hasn't flooded in 70 years there. We never expected this would happen. Our lender told us we didn't have to have flood insurance because we're not in the 100-year floodplain. Okay, you live on the Yellowstone River. Ice jams don't care about the 100-year floodplain. Okay, those are risks we have to communicate to people. The one on the right, this is Glasgow. That's the Milk River. That was just a few weeks ago. My question is, does the boat come with the $675,000 house? Because this house in 2011 had water in the basement. I feel bad for people that have these homes. They built them in the 60s, 50s. We didn't have as much flooding issues in those days. Now, the Milk River flooding is almost a, okay, yeah, no, pull out the plan. We know what we have to do. It's coming up again. Yep, the baseball field's going underwater. It's almost like we're becoming used to the Milk River flooding now in the last 10 years. So again, I feel bad that have these properties, but you have to realize no one's going to buy it. No one's going to buy these unless they absolutely don't know risk at all. So my ending is we need you. We have to have the research component in building a weather-ready nation. I don't know what all your disciplines are and where you work, but there's my email address. I'm on Twitter. You can Facebook Messenger me. I'm on LinkedIn. I am easy to find, okay? And several people in this room know how to get hold of me too. So we need you guys, and if you have ideas, if you just want to have a discussion, I'm always obviously happy to talk. So thank you for coming in here today. I appreciate it. Questions? And we have some people on the phone line too, right? So yeah. Yes.
So your weather ready nation, do you also put that in the context of climate change when you present that, or is that not?
We do. So it's a little long if you go weather, water, climate nation, climate ready nation, but it's all encompassed in that weather ready nation term, yes. It is. I wonder if we could. Yay, Chrome. Let's see. Go up here. Weather ready nation. About the devastating impacts of extreme events like cold, record-breaking cold, violent tornadoes, destructive hurricanes, widespread flooding, and devastating drought can be reduced by taking Advanced action, which is why the Weather Ready Nation initiative is so important. I don't see the word climate specifically there, but it does say future extreme events, and we know that one of the changes from climate change is we're seeing more extremes. So, but yeah, just to keep it short, it's Weather Ready Nation, but it definitely encompasses weather, water, and climate.
How much are local governments incorporated? So, kind of personal story is that my grandparents lived on the Red River, and that had
1997.
Yep. And I think it was like, I think 4 years ago or something like that, the Fargo bought up the entire street that they were on and just put a dike there.
Yep.
So how much do you guys communicate with local governments to get stuff like that?
We do our best. Now I have 12 counties in a reservation I work with. I know a lot of the commissioners. I know the LEPC, the Local Emergency Planning Committee folks. We work with them as close as we can and what they want us to. So we have some counties that they welcome us to every meeting. They want us there for everything. In other counties, it's just kind of hands off and we deal with things as they come. In 1997, when the Red River flooded the first time, this discussion of decision support and Weather Ready Nation really was not there. What they're doing these days when the Red River floods compared to 22 years ago is a whole different ball game now. And it's a lot more integration with EOCs. We actually send staff to EOCs to talk people through what's being expected. We do a lot of virtual conference calls and webinars. We did that on the Yellowstone River this year. All 3 forecast offices, Billings, Glasgow, and Bismarck, were involved in those ice jam calls. Where's the ice today? Where are we expecting it to go? What issues have we had? That way information is being communicated up and down, left and right down the river.
Do you do probabilities of killing frost? Or you know somebody who does that?
We don't specifically do it from our office, but I do know that the Midwest Regional Climate Center has done some work in that, and I can send you some information. But yeah, that is being done through some of the, I don't know if they're RESAs, Regional Integrated Science Assessment teams that are working with the regional climate centers, but I can get you some information on it.
Speaking of the RESAs, how much do you all work with the RESA out of Fort Collins or now Boulder?
I didn't even know what they did here until we held the first Montana Climate Summit a year and a half ago in Missoula. I'd love to have a lot more engagement with them, but I think we are all low staffed and pulled in 1,000 different ways. So we brought them all in the room and everybody talked a little bit about what they do and what their capabilities are, but to actually pull a project together and do something, we haven't reached that point yet.
Well, actually, on the recent map, there is no RESA for Montana.
Not really, no. She's right, yep. Not that it would stop us from asking any of them if we had some need.
I'm thinking of the USGS.
The hub, the USDA climate hubs, yeah. Those, again, same concept. We know who they are, we know we all exist, but to have actually integrated into Weather Service and them here in Montana, just not yet. Yeah.
Do you guys also do outreach to try and educate the public about what they can do to either biodiverse climate change? I know that agriculture is huge in climate change, and so do you guys talk to?
We do. So we get invited to a lot of the ag shows and the farm shows, and it's something we discuss and we talk about. We've never been like shot down in a huge way in a huge crowd, but what we find is people always linger afterwards to talk to us and talk to us about the changes they've seen. Now, climate mitigation isn't something we've done a whole lot on at this point because we don't have a lot of resources here in Eastern Montana. But we've hosted with the Corps of Engineers Go Green Days, where we show ways that you can recycle in the absence of recyclers in our region, and ways to, you know, swapping out LED bulbs. We demonstrated an electric car one year. So we do some of that if we're invited. The BLM has regional advisory groups that we've gone and given presentations at, and some of their big concerns are the backcountry roads and how, you know, we get these real wet events and the gumbo hits, and they're kind of concerned about the impact of all the people got to go four-wheel driving through it and show how much mud they can throw up, and it really does damage the ecosystems down in Southern Valley, Southern Phillips County, Fergus County, those areas. So you'll see the CMR now puts posts out there on their Facebook page. Please don't drive on these roads. This causes significant damage for us to repair. So not as much as we'd like if we had more staff and opportunities, but we do get invited to various talks that we do bring these things up.
Right, well.
It's all right.
Thank you very much.
Thank you guys for coming.